Now let's see few of the terminologies. So as you have observed, again and again I am mentioning one term, that is rigid body. So let us see what is a rigid body. So a rigid body, it can be simply defined as a body that doesn't suffer any distortion under the action of forces, right? So let us assume, let's say I have a body something like this, right? Now on this body, if I consider 2 points A and B, now what I did, I started applying forces, right, on this body. Now if the distance, for example, let's say delta D, if the distance between these 2 points, it is never going to change under the action of these forces, then this body, it can be called as a rigid body. That means there will be no deformation, right, within the rigid body or distortion under the action of forces. Now let us see what is a resistant body. So resistant body are the body that become rigid under certain specific conditions, right? So let us see some example. So for example, the most general example of a resistant body is simply your belt drive, right? So let's say uh, if you have a belt drive system, right? Let's say you have a belt drive system moving over a pulley. So you know that this belt, right, while in operation, it will always be under tension, correct? And because of this tension, right, this belt is going to behave as a rigid body, because again the distance between 2 points on this belt, it is never going to change until the belt is under tension. But as soon as you stop the operation, you will observe that there is little sagging in the belt, right? And now you can observe that under this condition, when this belt drive is not operating, what will happen? Under the action of, let's say, several forces, or you try to, let's say, tweak the belt, what will happen? The distance between 2 points on this belt, it is going to change, correct? And in that case, we can't say that this belt drive is behaving as a rigid body, right? So resistant body are rigid bodies, right, that become, right, rigid under certain specific conditions. So similarly, you can take the example of a fluid which is being compressed in a hydraulic press. So let's say if you take a fluid in a hydraulic press, and if you, let's say, compress this fluid to a certain extent, right, to a certain extent, so what will happen? After some time, the distance between two molecules of the fluid, right, it is not going to change, right? And in that case, we can say that this fluid system, it is behaving as a rigid body, right? However, nowadays, they usually, right, most of the authors or most of the engineers, they don't make any specific distinction between rigid body and resistant body. So these two words nowadays, they are used interchangeably. Now let us see what is the link. So it's very simple. A link, you can simply define a rigid body or a group of rigid bodies, right, with rigid connections, right, so that there is no relative motion between them, right? So let us understand this definition. So let's say you have simply a body something like this, correct? Now, so it could be a body of any, right, arbitrary shape. So right now I'm drawing simply a body of arbitrary shape, right? So this body you can consider simply as a rigid body, right? And this body, it could be a part of a mechanism, right? Obviously. Now let's understand what is meant by this. So this is a single rigid body. Now what is meant by this? A group of rigid bodies. So let's say if you have several rigid bodies. So let me just again draw some rigid bodies of arbitrary shape, something like this, right? So let's say you have several rigid bodies, right? But now these rigid bodies, right, they are connected through some joints. For example, let us assume that these rigid bodies, they are connected through some joints. But these connections, they are not allowing any relative motion between the rigid bodies. So they are not allowing any relative motion between these four, let's say, rigid bodies. So in that case, we can simply say that this group of 4 rigid bodies, it will simply act as a single link. Correct? So you have to be very clear at this point that a link, it could be a single rigid body or it could be a group of rigid bodies with no relative motion between them. Correct? Now let us move ahead. Let us understand what are the different type of link. So the first type of link is simply binary link. So what is a binary link? So a binary link, right? Two links can be connected to a binary link. That means it will provide two connection points, right? So one connection point could be this point, another connection point could be this point. Now in a ternary link is simply defined as a link where you can connect 3 other links, right? That means a ternary link, it is going to provide 3 connection points, right? So this is first connection point, this is second, this is third. Now what is a quaternary link? A quaternary link, obviously now it will provide 4 connection points. That means 4 other different links can be connected to a quaternary link. Simple. So similarly, you can go for higher order links also. For example, a penta, a hexa, and then a octa, and so on.